students, I, Dr. M.V.K. Srivani, Associate Professor from the Department of Chemistry, School of Applied Science and Humanities, present here to give brief explanation on mineral resources. My dear students, you have learned about resources which are very much useful to us. What is the resource? It is a source or support that is held in reserve. In our syllabus, we have different types of resources like forest resources, we have forest resources, water resources, land resources, energy resources. In addition to this, we have mineral resources also. Why we are learning about these mineral resources? Why these are so important? We knew that the minerals are the natural occurring substances present in the earth crust, and we utilize these minerals in various ways to prepare ornaments, in communication devices, in constructional activities, medicine, agriculture, right? We use these minerals. That's why they are very much important to us. And how we extract the minerals? There is one process which is most important, that is mining. Mining is the process that helps to extract the ores from the earth's interior, right? So, because of this mining, there are many environmental impacts are there. So, what we have to do as an engineer, what you will do to control these problems? You will apply some technology and create some solutions, so the problems can be controlled. That means, as an engineer, you should give the assurance that these minerals can be preserved for a long period of time, right? So, that is the reason they have added these mineral resources in your syllabus. Let us see in detail about the mineral resources. Now, coming to the objectives and outcomes of this lesson. These are the objectives. Let me tell you, the students can understand different types of minerals, its extraction and processes. Second one, the students examine the methods of extraction and their environmental and social impacts. To appreciate the need for conservation and sustainable use of mineral resources, and to propose engineering solutions for efficient mineral use and reduce the environmental harm. I told you, there is an environmental harm. As an engineer, you should provide some solutions to control these issues. Okay? So, now after learning this lesson, what is the outcome? You can see here, students. The students can identify and classify mineral resources and explain their importance in engineering applications. This is one outcome. Next one, the students can analyze extraction processes and find out their environmental consequences. That is a second outcome. The students can apply environmental ethics in the use and management of mineral resources, and they can recognize the need for lifelong learning in emerging areas of sustainable resources use. These are the outcomes of this lesson. Now, you can see the introduction, students. I told you about the minerals. Let me discuss once again. The minerals are the fundamental building blocks of rocks and essential materials in modern technology. It is a natural occurring solid inorganic substance. See, every mineral has definite chemical composition and it has its own physical properties, right. Based on the physical properties only, we can identify the minerals. Clear? This is a natural substance found in the earth which is not made by plants or animals, right. And we utilize these minerals, I told, okay, we utilize these minerals, see in buildings, that means in construction activities, to prepare jewelry and tools. They have given some examples here: iron, gold, copper, bauxite, right. Now, the most common minerals in the earth crust can often be identified in the field. I told you, with the help of physical properties. What are they? Color, shape and hardness. These are the physical properties. Based on the physical properties, we can identify the minerals. You can see this picture, students. These are all the different types of the minerals. These are some of the examples given in this slide. Let me tell you: talc, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, corundum and diamond. Okay. So, these are some of the minerals. I have given some examples. Now, the minerals are used in large number of ways. I already discussed this. No need to learn about the uses. So, you critically analyze and think. You can give the answer. That means, how, in what way we are using these minerals. See, for example, these minerals are used in development of industrial plants and machinery, helps in generation of energy. You can give an example of coal. You can give an example of uranium here. Constructional activities, settling and housing, we use the minerals. In transportation, communication, cable, wires, electronic devices. Even in medicinal system, agriculture and jewelry, we utilize these minerals. So, that is why these are very important, and the minerals are the symbol for national development, right. Now, mineral production. So, let me give you a small statistics about this mineral production. So, you can see here the provisional total value of mineral production. I repeat, the provisional total value of mineral production excluding atomic, fuel and minor minerals for 2023 to 2024 is estimated to be 1,41,239 crores, representing a growth of approximately 14.83% over the previous year. That means they have seen that estimation. So, 1,41,239 crores means there is an increase. Okay, that is what they are telling, that representing a growth of approximately 14.8% over the previous year. When they have seen in the previous year, it is less, and in 2023 to 2024 there is an increment, there is an increase. Okay. Now, the provisional value of metallic minerals during 2023 to 2024 is estimated at 1,27,599 crores. This is metallic mineral constituting 90.3% of the total value of mineral production. That means you imagine how much mineral production is happening. You can see. In comparison, the production of non-metallic minerals is valued at 13,640. See what is more here? Metallic minerals. Okay, that is what they are explaining here. Non-metallic minerals is valued at 13,640 crores, accounting for 9.7% of the total value. These figures, whatever I explained, these figures underscore the predominance of metallic minerals. That's what they are telling. Compared to the non-metallic minerals, the metallic minerals, there is a predominance of metallic minerals in the overall mineral production value. So, this is some of the statistics of mineral production. Now, India produces as many as 95 minerals. You write approximately. Don't write completely it produces 95 minerals. You write India produces as many as 95 minerals, including fuel, metallic, non-metallic, atomic and minor minerals. Clear? Now, all of you look at this index of mineral production. They have given years. Let me turn this side. You can see here all of you. 2017 to 18, 104.9. 2018 to 19, 107.9 and 19 to 20, 109.6. In the year 20 to 21, there is a problem. Everybody knew the pandemic, right? So, in the year 2021 to 22, 113.3 and coming to 2022 to 2023, 119.9 and if you see in 2023 to 2024, it is 128.9. You are seeing there is an increase. Okay? See, in 2022 to 2023, it is 199.9. When you have seen or observed in 2023 to 2024, it is 128.9. See, that's what I explained. The same was explained here in this slide. The index of mineral production for the year 2023 to 2024 is projected at 128.9 compared to the previous year. I just now have shown you in the slide, in the previous slide, right? Compared to 119.9 in the previous year. That means what it is saying here, there is a positive growth rate of 7.51% indicating a steady improvement in the mineral production. Okay? So, when they observed year wise, there is an increase in the mineral production because that much important the minerals are. Okay? You can see. Based on the properties, minerals can be classified into two types. You already learned this long back, but let me just give some small explanation regarding this. So, based on the properties, minerals can be classified into metallic minerals. You can see here. They have given examples: gold, see, silver, gold, aluminum. They have given examples. Non-metallic minerals, they have given some examples: mica, limestone, gypsum. Can you tell me what is the difference between these metallic and non-metallic minerals that you have learned? Okay. See, metallic minerals, they are having shine. Okay. They are ductile. That means they can bend. They are flexible. They are found in igneous rocks, metamorphic rocks, metallic minerals. Okay. Whereas these non-metallic minerals are found in sedimentary rocks. Metallic minerals are good conductors of heat and electricity, whereas such type of properties are not there in the non-metallic minerals except few. Understood? So, this is about metallic and non-metallic minerals. All of you see here. So, when I explained starting, I told you about mining. Mining, I don't say it is not important. It is very, very important because we need minerals for various purposes. Clear? So, but there are some issues that we have to take some responsibility to protect the environment, to control the issues. Okay? So, now you can see mining. I told you mining is the process of extracting valuable minerals or other geological materials from the earth. It is an important segment of Indian economy, mining. Minerals include metal ores. I have given examples about metal and non-metals. Again I repeat, no issue. Iron, gold, copper, non-metallic minerals like limestone, gypsum and fossil fuels like coal and oil. Mining is essential for industrial development, but must be managed responsibly due to its environmental impact. That is why we are very much worrying about this mining. Okay? So, mining can be done, but at the same time we have to take up some measures to control the environmental impact. That means, we have to give assurance that these minerals can be preserved for a long period of time. Okay? Now, how these minerals can be extracted? I will tell you briefly. Okay? They are the following stages of mineral extraction. You can see here the first one, exploration, second one, planning and development, third one, extraction, fourth one, processing, and fifth one, closure and reclamation. Right? So, these are all the different stages of mining. What is the first one here? Exploration. What is this exploration? Searching and finding the mineral. That is exploration. So, after finding the mineral, they will plan and development. That means ready to mine. They will take permission from the government. They will assess. They will estimate. Okay, how much cost, everything they will do, and they will make it ready to mine. That is planning and development. That is what they have given here, simply ready to mine. After this, we go for extraction. Everybody knew extraction means extraction of the ore, extraction of the mineral. Here we will use different methods of extraction, right? So, after extraction, we go for processing. Clear? Here cleaning and separating. Next, after processing, the last stage is closure and reclamation. See what they will do here? They will close it and clean the site. Whatever the overburden is there. What is overburden? Overburden means that during extraction processes, we get large amount of waste, mining waste, mine tailings, acid mine drainage, all these we get, right. So, all these should be immediately cleared. They will remove it, they will clear and they will go for reclamation. That means they will grow the plants there again. Understood? So, these are the stages in mining. Understood? Now, you can see here there are different types of mining. I already explained to the student about the mining operation. After this, what are the different types of mining? So, I have to explain all these in detail. Let me discuss what are the different types of mining. The first one, you can see here all of you, the first one is surface mining. I did not give you examples because surface mining is again classified into following types. Okay. So, next, underground mining. This is also again classified into various types. Placer mining, in situ mining. So, these are the types of mining: surface mining, underground mining, pleasure mining, in situ mining. Clear? So, let me discuss one by one in the next slide. You can see all of you. The first one here, that is surface mining. Here minerals extracted from the surface of the earth. The name itself indicate, right. So, I will in the next slide I will explain this surface mining can be classified into various types, right. So, now subsurface mining, this is nothing but underground mining. Okay. Minerals extracted from the underground or deep beneath the earth surface. Next one, placer mining means extraction of ores from the river bed, that is placer mining. Here gold, tin and gemstones, these are the examples in the placer mining. Clear? Now, in situ mining, here what they will do in situ mining? They will pump a chemical solution into the ore so that it dissolves. After dissolving and pumping it back up, this is in situ mining. I repeat, pumping a chemical solution into the ore to dissolve it and pump it back up, that is in situ mining. Example, you can give uranium, salt, lithium. Is it clear? So, these are the different types of the mining. Understood all of you? So, now coming to the types of surface mining. I told to the students, surface mining means the minerals that can be extracted from the surface, okay, from the shallow regions, that we call it as surface mining. So, it is again classified into various types. Listen here all of you. First one is open pit mining. We call it as open cast mining also. Next one, strip mining. Next one, quarrying. Next, mountain top removal. Okay. So, open pit mining, strip mining, quarrying, mountain top removal. These are the types of surface mining. Clear? Now, you can see all of you this picture, it shows open pit mining. See how they made the pit. Here, what they have done here, see, large pits are dug to extract the minerals. Okay, how they made the pits with the help of the machines. Understood? So, in this picture, it is clearly shown how the pit was made. Right? You can give here examples of copper, iron. Is it okay? So, now coming to the other one, strip mining. What is strip? Pieces, layer. That is the meaning of strip. So, what they will do here? You can see here strips of soil and rock are removed. See how they removed? In the form of layers, strips. Strips of soil and rock are removed layer by layer. See, in the form of layers, it is, this picture clearly shows that layer wise how they removed. Okay. That example here is coal. Understood? Strip mining, later quarrying. So, what is this quarrying here? Here explosives, I mean bombs are used to burst that particular area. That is quarrying. They make quarry. You can see here in Vadlamudi, when you go by road, when you go by bus, go on road, then you can see the quarry which is closed. Okay, they used explosives and burst that particular area and they made quarries. Understood? To extract the ore. Now, this is a place. What is the quarry? Quarry is the place where stone, sand, etc. is dug out of the ground for use as building material. Okay? The place where the stone, sand are removed from the ground for use. Understood? We use it for building. Understood? It is used to extract building stones like marble, granite and limestone. Is it clear? You can see the next one. The name itself indicate mountain top removal. What they will do here? They will blast the top of the mountain. See here, they will blast. The mountain is there. Here if the coal is there, if the ore is there, they will blast that. Okay? So, they will blast the top of the mountain and remove the ore. Okay? Example here, coal is the example in the mountain top removal. Now, coming to the other one, you can see here all of you, types of underground mining. Types of surface mining is completed. Now, let me discuss the types of underground mining or subsurface mining. The first one here is drift mining. Second one, shaft mining. Third one is slope mining. See, you can see whether it is visible or not. You can see here drift mining, shaft mining, slope mining. What is drift mining? Let me tell you. Here horizontal tunnels are made into the side of the mountain. Remember in one point, in drift mining what they will do? They will make horizontal tunnels into the side of the mountain to extract coal, gold. These are the examples of the drift mining. In the next slide, I will show you the pictures. Is it clear? So, now you can see shaft mining. What is a shaft? Shaft is a large sphere like equipment, right? So, that is shaft. Here vertical shaft are dug to reach deep mineral deposits. If the ore is inside very deep, then they will utilize the vertical shafts and dug. That is what they are explaining. A vertical shaft is dug to reach deep mineral deposits. Example, diamond, gold and uranium. Next, slope mining. What they will do here? Angled shafts follow the mineral seam underground. You can simply write, make slope tunnels to extract the mineral. Example here, you can give coal, lignite, copper. These are the examples. Is it clear, students? Types of underground mining I explained. Drift mining, shaft mining, slope mining. Now, you can see this picture. You can see this picture, all of you. I will come this side and explain. Listen, this picture explains the drift mining. See, coal seam. It is nothing but layer. Okay? So, layer of this coal is present here and this is surface. What I explained in the drift mining, horizontal tunnels I told to the students. So, the transfer house, preparation plant and what is this conveyor belt? Conveyor belt, it helps in transporting the extracting material to the processing site. Understood? That is the use of conveyor belt. What it will do? It helps in transportation of the extracted materials from its place to the processing site. Clear? So, this picture shows the drift mining. Next, See all of you, shaft mining. I told to the student, shafts are used when the minerals are very deep. Is it clear? So, in this picture, they have shown the vertical shaft, all of you see here, vertical shaft. Here they have also shown like this, surface mining also they have given here. All of you look at this picture, surface mining, see the ore when close to the surface, understood. Here sloping ore body, this is a sloping ore body, and here horizontal tunnels from main shaft to reach ore. Horizontal tunnels are made here to reach the ore from the main shaft. Okay. So, this is the picture showing the shaft mining. Here they also have shown, see, surface mining for shallow ore. So, how they are doing? Horizontal tunnel they are using from the main shaft to reach the ore. Is it okay? So, now coming to the other one, see all of you in this picture you can clearly see the shaft mine, the first picture, slope mine, second picture, drift mine, open cast mine. I told to the student, open cast mine means open pit mining only. Is it clear? So, now you can see in this picture shaft mine. They clearly explained here in the shaft mine. All of you look here first, preparation plant, main shaft. Here you are seeing shaft. I told shaft is nothing but a large spare like equipment. I told you are seeing here main shaft. This is air shaft. What is this air shaft? See, air shaft to pump the fresh air into the particular place. It helps to pump the fresh air. It is useful for ventilation and also to remove the contaminated air. Understood? That is the use of the air shaft here. Clear? Vertical shafts are made here. So, this is coal. Shaft mine example. Slope mine, all of you see, air shaft I told. What is the use of air shaft I told to the student. Now, here see, preparation plant, slope tunnel. Slope mine, see this is a slope tunnel you are seeing here. This is the coal. Slope tunnels are made here to extract the mineral. Clear? So, now you can see here, this is drift mine, this is coal, drift tunnel, horizontal tunnel I told to the student. So, here you can see drift tunnel is made here, this is conveyor and this is preparation plant. Now, open cast mine, this is drag line, this is coal. What is this drag line? Drag line is a machinery equipment. Okay? Drag line is nothing but a machinery equipment to remove the ore. Is it clear for you, all of you? So, in this picture, you can see here very clearly shaft mine, slope mine, drift mine, open cast mine. Is it clear? Students, till now I covered about mineral resources. I have given introduction of mineral resources, mineral production, mining, stages of mining, types of mining. In types of mining, I explained about surface mining and its types, underground mining and its types, placer mining, in situ mining. Okay? Till now, the types of mining is completed. Okay? So, okay, everybody knew about mining. These are the different types of the mining. They are causing impact. Here, no need to study about the consequences. I explained about the process, how the minerals are extracted, what we are doing. We are using some explosives. We burst that particular area. We are making tunnels Before this mining, what we are doing? If you identify the mineral, we remove the vegetation there. That means there are some consequences due to this mining. Okay? During mining, after mining, also there are some consequences to the environment. That is what I am going to tell you. Point wise, you can see, just I read, all of you see here, degradation of land. I told, after searching mineral, we remove the vegetation, okay, which leads to deforestation. That is one problem. Next, we use explosives and burst that area. Understood? So, if you burst like that, if it is not cleared properly, it leads to land degradation. Okay? If the land degradation continues for a long period of time, it results in desertification. Next, pollution of ground, surface water. You can even give air pollution also. Because of the mining waste, impact on the growth of vegetation. I told air pollution, also deforestation including loss of flora, plants, fauna, animals. There are so many consequences you can give, right? See, physical change in the land, water and air associated with mining, and earthquakes and landslides because of the pressure, fire hazards and accidents, mining accidents which are hazardous. Okay, number of the people die due to this mining accident, permanent damage to landscape, aesthetic of the surrounding. Aesthetic is nothing but beauty. Okay, aesthetic view of the surrounding is lost. I know you knew about mine collapse, mining accidents. The roofs sometimes collapse and kill the people. Fire, example methane, coal dust, etc. Okay, so these are some of the consequences of mining. And in the next slide, you can also give examples of health hazards. Can you tell me how our health is affected? So, if the person or the worker, he is working in mining industry, what will happen? He will inhale to the dust which is present in that place, right? So, definitely it affects the health of the worker. Okay? So, now you can write health problems. See in the next slide, health problems. Pneumoconiosis, it is nothing but a type of lung cancer. Next one, asbestosis, inhaling asbestos fibers for a long period of time, cancer. Silicosis, inhaling silicate dust, it is one type of cancer. Heavy metal poisoning, you can give example mercury. Radiation exposure in uranium mining. In uranium mining, radiation exposing. Okay, so these are all examples of the health problems. Understood? So these are all the consequences of mining. Now what we can do? That is very, very important. We have to do something to control the problems. I can tell you, we go for conservation. In the next slide, I am going to discuss about conservation of minerals. Okay? All of you see this one, conservation of the minerals. Conservation refers to the sustainable and efficient management of Earth's non-renewable mineral resources. Minerals form over geological time scales millions to billions of years. I can say that these minerals are the non-renewable resources. So, conservation of the minerals is also needed. Understood? We have to preserve these minerals for a long period of time. So, that is why we have to go for conservation. That is what they are telling here. It is vital to ensure, that means we give assurance their availability for future generations, and also to minimize environmental harm. Okay? We have to control environmental problems, at the same time we have to preserve the minerals. Okay? Now what we can do in the next slide, some of the examples what we can do to preserve these minerals and control the impacts. These are very important. The first one, let me explain. Recycling and reuse, one of the important technique, best technique, 3R technique. Okay? So now here reuse metals like aluminium, copper, fly ash and slag reuse in construction. Instead of wasting, reuse it. Why to waste? Efficient use. If you use efficiently without degrading anything properly, then nothing happens. Right? See, maximize yield, minimize waste in extraction and product use. Example, processing low grade ores to make them unstable. Next, reduction of waste. One of the important step here, whenever we do mining, overburden I told to the students, overburden, that overburden should be immediately cleared. That will become a very big problem later. Avoid unnecessary byproduct disposal. Some example. Okay, you can give many points. Next, substitution and alternatives. Use alternatives instead of metals. Replace scarce materials with more abundant ones. Reclamation, I told. Restore mined lands by plantation, filling pits. That's very important. After closing of the mine, you restore it. In reclamation, I told, okay, grow some plants, vegetation, make garden, make park. Okay, so these are some of the examples here which we can control the issues and also conserve the minerals. Is it clear? Now, conclusion. What we can conclude here after learning this? So, we knew that mineral resources are most important. See, these are essential for the economic development and industrial growth of any nation. They provide raw materials for construction, manufacturing, energy production and various other sectors. So, it is crucial to use them wisely. That is what I told. Go for conservation, preserve the minerals. We have to use them efficiently and sustainably. Means proper use it, conserve it. That is sustainable utilization only. Negative impacts can be reduced by doing recycling. I told, reduce, reuse, okay, and using efficient mining technologies. Okay, so I conclude that these mineral resources are very important, but there are some environmental consequences are there. We have to take up the responsibility to control these impacts, okay, and also we preserve the minerals for a long period of time. As an engineer, what you can do? You suggest some measures or you apply some technology and control the problems of mining. Is it clear? These are some of the references that I have taken from the website, and finally, thanks to everyone. In this lesson, I covered mineral resources introduction, uses of minerals. I have given some explanation about mineral production, statistics, mining, stages of mining, types of mining, consequences of mining and conservation. Thank you all.